So now that we're on the topic of like horizontal and vertical things, let's go over horizontal and vertical lines. Okay, so let's do horizontal first. So horizontal line. So that has the form of f of x is equal to b, a constant, right? And you know how before b has represented in the past our y-intercept, right? It doesn't mean anything different in this case either. So basically, when you plug in a 0, so if we were to plug in f of 0 is equal to b, we would just get b as our output, right? And that means that's our y-intercept. Also, this also means that when you plug in any x value, we're still going to get b, okay? If you plug in anything you want, just keep trying the function out, you're still going to get b. Sorry about that, but it's what's called a constant function, okay? So this is called a constant function, and it looks like what the name says, implies, a horizontal line, right? So let's say here's b, the y value of b, our line would look exactly like this. So this is our f of x is equal to b. And as you'll see, the horizontal line also has a slope of 0, right? Because the value of the function doesn't change with any given change in x. As we keep going left and right, the function just stays the same. Alrighty? Okay, so now how about vertical lines? Vertical lines. These have the form of x is equal to some constant, okay? That's a little bit weird because it's like, well, where's the f of x part? So that's the thing. There is no explicit f of x because it's basically infinite. So x equals a, let me show you an example. I think that'd be better. So let's say x is equal to 3. This equation would be graphed by the following. So we have our x and our y. Let's say here's x equals 3, right? So this is 3 here. And we have a line, a vertical line that is, going straight up and down, continuing up and down to infinity. So in this case, our slope is undefined. That means we have a 0 on the bottom, right? Because if you take any 2 points on here, let's say 0, 3, or sorry, 3, 0 is that bottom point, is the x-intercept, right? And let's say this is, I don't know, 3, 5 or something, 3, 5. If you were ever to take the slope of 2 points, we would get any y change, and then 3 minus 3. Because the x component, or the x coordinate in this case, x coordinate is always going to, the difference is always going to be 0. So we get 5 over 0, which is undefined, right? Okay, now let's go over parallel and perpendicular lines. So we'll start with parallel. Parallel lines. And it's usually denoted by the symbol of like 2 slanted lines being parallel to each other. Okay? So parallel lines mean that 2 lines are parallel if they have the same rate of change. Okay? Same rate of change, aka the same slope. Aka same slope, m. Okay? So they don't necessarily have to have the same b, so that's an important point to make. Don't have to have same b or same y-intercept. Okay, they can cross wherever they want, but they just have to have the same slope. Okay, so here's an example. Let's say we have f of x is equal to 2x plus 4, let's say. And g of x is equal to 5 plus 2x, okay? So in this case, we have the same slope, 2 and 2, but we have different y-intercepts. So let's see what this looks like graphically, okay? Okay, so we have x and y, okay? So then we have 1, 2, 3, 4, 5, 6, 7. So here's 2, 4, 6. And then I'll go 1, 2, 3, 1, 2, 3. Okay, so let's graph f of x. So we have a y-intercept of 4, then we go up 2 over 1, down 2 to the left 1 to graph that line. Okay, so our line for f of x looks something like this. Alrighty, let me label that here. So this is f, alright? Now let's do g. So that one has a y-intercept of 5, okay? And now that one we still go up 2 and over 1, down 2, and over to the left 1. Okay, and then if we graph that guy, it looks like this. And I'm trying my best to make these look parallel. Okay, so there's g, that's the top one, or the upper function, okay? So see how, because even though they start at different points, it doesn't really matter where the y-intercept is, but because they have the same slope, that means for every 1 unit change in x, then they're still going to be changing the exact same in our function value, okay, or change in y, okay? So that makes them parallel to each other. Now let's go over a different case we could have between two lines. Let's say two lines are perpendicular, and I cannot spell, so let me try that again. There we go, perpendicular. There we go, I thought there were too many I's. So perpendicular lines, and that's denoted by this symbol. It's kind of like an upside down capital T, okay? And that basically kind of tells you everything that goes on is because these two lines, or any two lines, are perpendicular if their slopes, we'll call them m sub 1 and m sub 2, have the following relationship. Okay, and that relationship is that let's say m sub 1, is equal to the negative reciprocal of the other. Okay, that might look a little bit weird and fancy, but we're kind of just going to take it as it is. Okay, so basically they form right angles at their intersection. Okay, so these two lines form right angles, and I'll just denote it by this, form right angles at their intersection. Okay, intersection. Alright, so an example of this would look like the following. So we could have this equation, which is the same as saying m sub 2 is equal to negative 1 over m sub 1 as well. That's the same thing. They're negative reciprocals of each other. Okay? So let's see an example. Let's say we have this f of x is equal to our same 2x plus 4. But this time, g of x is equal to, 5 minus 1 over 2x. So see here how m sub 1, the first slope is equal to 2, and the second slope is equal to negative 1 over 2, which is the same thing as saying negative 1 over m sub 1. So see how that's the negative reciprocal, right? And the way we would graph this, let me show you guys. So say we have x and y, and that is not completely vertical. We're just going to continue anyways. So 1, 2, 3, 4, 5, 6, 7. Okay, 1, 2, 3, and 1, 2, 3. Alrighty, so the first one, we'll just graph that real quick. So 4, and then 1, 2, 3, 4, and then up 2 over 1, down 2 over 1. Okay, so we have a graph, or, a line looking like this. This is our f, okay, so that's f. And then we have this one crossing at 5, but now we go down 1 and over 2. Okay, that's what negative 1 over 2 means for our slope. And then up 1 and to the left 2. So something looking like this. Okay, and then as they cross, if we were to zoom in, let's say, we would see a line looking like this and a line looking like this, and thus they make a right angle at their intersection. Okay, so an important thing to note is that perpendicularity, or having perpendicular lines that make a right angle, is a special case of an intersection between two lines. Special case of intersecting lines. Again, I cannot spell. Intersecting lines. There we are. Okay, so then the question is, well, when do lines intersect? So this is important. So intersection between two or more lines, will arise when two slopes, or when slopes, we'll just say, when slopes m are unequal. When they're not exactly equal, so when they're not parallel, when two lines aren't parallel, then they're bound to intersect somewhere, okay, at some point. Okay, so let's do an example showing the intersection and finding an intersection between two lines. Okay, so here's a problem we can practice on finding that intersection. So we have h of t and j of t. Okay, so our goal is going to be, first, what we want to do, we want to find the t value where the function values are equal. So where h of t is equal to j of t. Because that would mean at the same t, at some particular t, these two meet up. These two functions have the same value, right? So what we have to do in order for that is just replace this h of t with its formula, and replace the j of t with its formula. Okay, so that just means we're going to write in 3t minus 4 for the left side and a 5 minus t for the right side, and then simply we just solve for t. Okay, so I'm going to add this t over to the left side. Okay, so we get 4t minus 4 is equal to 5. So 4t is equal to 9 when we add the 4 to the right side. And then finally we have t is equal to 9 over 4. Okay, so this isn't the intersection point because it's only one coordinate of it, but we could find the y value or the y coordinate by simply plugging this into one of the equations, okay? And it doesn't matter which equation you plug it into because we found at this point, at this t value, we're going to have the same value of both of our functions at the same time, okay? So let's just say we plug it into h, so then we have h of 9 over 4 is equal to 3 times 9 over 4, and then minus a 4. So this is equal to 27 over 4 minus 4, which we can rewrite as 16 over 4. So we just get that this is 11 over 4 for the value there, okay? So we would write this as, and you could see, let me just do it for you so you can see it here. So j of 9 over 4, if we were to plug it in there, we would get 5 minus a 9 over 4, which is 20 over 4 minus 9 over 4, which equals also an 11 over 4, okay? So this is the intersection, so we would write the intersection point as t, comma, whatever the function value is. So 9 over 4, comma, 11 over 4. Alrighty, and that's the intersection between these two lines. Okay, that concludes the concepts video for the section on graphs of linear functions. I hope that helps, and I'll talk to you in the practice problems video if you watch.